Good afternoon and welcome to another lesson for National 4 and 5 Computing Science for Bravey Academy. Once again, Mr. Snedden here. So, we'll get started. What we're looking at today is we are going to be looking at extending our understanding of a binary. In particular, we are going to find out how binary is used to store characters using both extended ASCII and Unicode. We'll be finding out the differences between characters and regular characters, and also we'll be looking at the range of characters that can be stored within the two types respectively. So, first of all, what happens when we try and communicate with a computer? Doesn't matter what program you're using, you'll be interacting with the computer in some form of way. Usually when you're typing away on a keyboard, the program has to have some way of identifying what happens when you press keys. Each key is essentially connected to a little switch that sends a signal into the computer, and the computer can process this input and translate it into a binary code that the system can handle. Doesn't matter what kind of package, game, program, whatever it is, this happens on the basic level. When we're looking at individual letters, keys, characters, they all have to have a unique way of being represented in binary. This is much like the numbers that we were dealing with in the previous lessons. Every denary number that we use has to have a binary equivalent that can be conveyed in ones and zeros very simply, that the computer is able to process it. Because as we know, computers are brilliant machines, but they're dumb. We have to give them information in a format that they can handle. So, the most common method that we'll be learning about is called extended ASCII. To start us off, ASCII stands for the American Standard Code for Information Interchange, and this was one of the earlier systems that were set up to store letters in a format that computers were able to handle. Then that was developed on because they needed more characters to represent the letters, numbers and special keys that we have, so extended up from 7 to 8 binary digits, and these can be used to represent 256 characters. You'll notice that's the exact same as the number of binary numbers that we can represent using 8 bits. And altogether, this was known as a character set. Included in extended ASCII, the character set has different subsets of keys. We have non-printing characters. Now these are keys that carry out a function that doesn't appear as something written on the screen. Things like return, which creates a new line, or select enter. You've got your tab keys, your backspace, your delete, all these buttons that carry out a specific function that doesn't show up as text or numbers. We have our numbers, 0 to 9, which allows us to represent all denary numbers, regardless of how many numbers are actually making up. And then we have upper and lowercase characters for making for a total of 52. And then lastly, we have our punctuation and other symbols. As you can see, I've listed some examples there. Extended ASCII allows us to represent 256 characters, which for English covers us really pretty well. We have, as we've covered, 26 letters. We need lowercase, uppercase. We've got our numbers. We've got our punctuation. Extended ASCII tends to do the job for our language. However, in other languages, they have a lot more characters. So Unicode was created using 16 bits, and as you can imagine, that extends the options up exponentially. Here's just a small sample of an ASCII table. You can see we have our control characters down here, showing the light blue colour shows what the symbol is. The red is the hexadecimal code, and the blue is the denary version of the binary number that it would represent. This is just a wee example to show you some of the options there. As I mentioned, when we were dealing with English, extended ASCII tends to be suitable for our language requirements. However, when we look more globally at expanding software and making it suitable for all countries and all languages, we have to deal with the barrier of not having enough characters. So ASCII, as I've mentioned, was developed and was made to use 16 bits rather than the 7 of ASCII and the 8 of extended ASCII. By doubling the amount of bits allocated to each character, Unicode is able to change simply 256 characters that extended ASCII can offer up to 65,536. Don't worry, you don't actually have to remember the exact number. You do need to remember, however, that Unicode allows us significantly more characters for significantly more languages, but it does come with the penalty of requiring double the amount of storage that ASCII would for storing the same information. ASCII is all fun and games. Sometimes people like to make little characters. If you get into coding yourselves and you have a wee look at some program files, particularly smaller games, some people tend to include little images made up entirely of characters. Here we've obviously got Homer Simpson and good old Captain Buzz Lightyear. So that's us for today, covering the topic of ASCII in Unicode. Now, what I will ask you to do is log into our Microsoft Teams as usual. Then there are a few questions posted as an assignment. This has been set due for Friday, the 5th of June. So this coming Friday. You can still submit work up until Monday at 9 AM where it closes so that I can get them marked. Please feel free to make use of the PowerPoints that were posted, in addition to the written notes, and obviously this video as well. If you do have any questions or any issues, please get in contact with me through the usual channels. You can post on your Teams with a little question, or you can email me directly at the usual email address. Thank you very much, and I will see you all later on.